Hello, this is Shakil Ahmed. In this video, we will discuss about correlation analysis. Correlation is basically the relationship between different variables. And when we come to the correlation, we are assessing the relationship between the uh, continuous variables or the quantitative variables when we are interested in evaluating the relationship between qualitative variables, then we say that is an association studies, and we can do we can check the relationship between the qualitative variables as well. So in this tutorial, we will discuss the correlation for single variable, two variables, or more than two variables, and we can find the scatter plot and scatter plot matrix, and we see the scatter plot matrix with correlation matrix as well as the density plots for all variables, and finally will get a heat map presenting the strength of association or strength of relationship between the variables. So let's start with the working uh, codes. So we have library that is called and the foreign that is used to import the data. Basically, this data is already in our iris flowers data, which includes the flower sepal length, sepal width, and petal length and petal width of the iris flowers, 150 iris flowers. And we can just see uh, the data. And now we start with simple Pearson correlation. Pearson correlation is a parametric correlation measure that tells the strength of association between the two quantitative variables. I'm just finding the correlation between sepal length and sepal width. You can see that is minus 0.11. That is very weak and negative. And then we can find the a Spearman correlation, that is a non-parametric version of the uh, correlation coefficient, estimate of correlation coefficient that is obtained from the rank data. Basically, for Pearson correlation, we should have a data on the ratio scale, but when the data is not at the ratio scale, we have at least we have rankings. We can find the Spearman correlation. So this is a non-parametric version of this. And we can just display the correlation for all variables among all variables using correlation, then the data frame. And I'm excluding the fifth variable. As you can see, we have five variables. The fifth variable is a qualitative variable that describes the species of the flower. So we can't include it in correlation analysis. So you can just find, and we are rounding the results to two decimal places. We will get the correlation matrix among four variables. Now we can see the correlation between the sepal width and sepal length is minus 0.12, and sepal length and petal length is strong and positive with a 0.87. So this is the correlation matrix, and if the value of the correlation is -1, we can say there is a strong negative relationship. If the value is closer to 1, then there is a strong positive correlation, and if the value is closer to 0, then we said there is no linear relationship. There might be a non-linear relationship, but we just say there is no linear relationship between the two variables. And we can find the scatter plot for two variables. Just plot and then x and y, two variables, sepal length and sepal width, and you can give the title. You can give title to the x-axis and y-axis, and just see This is a simple correlation matrix, length of sepal and width of sepal, and this is called the scatter plot. And if there is uh, if the points or dots are in form of an ellipse, we can say that there is a relationship. Here there is a weak relationship there. We can't determine an exact linear relationship between length of sepal and width of sepal. That is very weak. And then you can find you can test whether the association is a relationship correlation is significant or not. You can do the correlation test. You will get the test statistic and the p-value. It is applied the t statistics, and the p-value is 0.15, which is not significant, which is greater than 0.05. So the true null hypothesis is accepted. It means the correlation is zero. Means there is no linear relationship between significant linear relationship between the petal length and sepal length. So now we can find the correlation matrix for uh, all variables, uh, and again we can test whether there is a significant relationship between different pairs or not. Uh, Here we are only tested for two variables. Now we can see the relationship between different variables in our data set. And this is an important thing while doing, for example, you are doing a regression analysis and you want to see how different variables, different covariates are related to your dependent variable. You can just do that. You first take your data, and just you need to put the data and write it in a matrix form. I am again excluding the fifth variable, and then R correlation. It will provide the test statistic and p values and the R value of the correlation as well in a matrix form. So you can just run. You will get two matrices. You need to run this library HMISC package. I have already installed. If you have not installed, you need to install. And then you can see, and this is the values of the correlation. R, as I have given R, the result will consist of R, P, and other estimates as well, like standard error. So you can see this. You can see what other things are in this result. You can just see R, N, and P, and type. So these are all available in your result. So we just found the p values and the r values. You can also see the t values and the type as well, type of the test. And then we can plot the correlation matrix with scatter plot as well as the densities. So uh, this correlation matrix is giving basically this plot as well. This is a 4x4 matrix, which is giving the scatter plot between different pairs of variables. But we get the same thing using the GGA double LY command and with GG pair. Now it will include all the things. You can see the correlation matrix between different variables, for example, sepal length and sepal width. And this is density for sepal width, this is density for sepal length, and this is the correlation value between sepal width and sepal length. And it also gives the significant code. This is it should be mentioned at the end that the three static means the result is significant on at 0.001, at least 0.1% it is significant. So you have all the things in this single table. So I recommend to use this type of presentation while if you are interested in exploratory data analysis. Before conducting your study, you want to just see the relationship between your variables in your data. And the last thing we will show is the correlation matrix using a heat map. And this will also give a correlation matrix with the with different colors with different intensity. You are basically visualizing with different colors. So GG correlation matrix, and this is again the overall data frame, which consists of 5 variables. I am excluding the fifth variable. And if you write the type parametric, it will give the Pearson correlation. If you type it as non-parametric, it will give the Spearman correlation. So you can just run this command and see. Now you get the correlation between different pairs and in terms of a matrix. And here is the legend. You can see the red, the density of red is showing the negative correlation, and the density with blue color is showing the positive relation, and the light color in the middle is showing there is no relationship. As we can see, there is no relation, there is no significant correlation between sepal width and sepal length. That is 0.2, and the cross means non-significant at p-value is less than 0.05. So this is also an attractive thing where you can see the insignificant values, and you can see the strength with different colors, positive, negative, and no correlation. So that's all about the correlation analysis. Uh, Thank you for watching, and don't forget to subscribe if you still not subscribed.